Hi! This class is going to focus on cloud computing. Nowadays, although information technologies has become widely used both at home and at work, the industry is still in its beginning. Cloud computing, one of the latest information technology innovations, is not following a different trend, and it is still definitely in its down. I know, this seems to be rather far from the topics we are used to, but believe me, it is not. It is not far at all. Let us try to get closer to this topic, starting from what we know better: FPGA devices. Distributed system, data center, and cloud architecture are facing the exponential growth in computing requirements and the impossibility for CPU-based solutions to keep pace. Within this context, these complex distributed systems have to move towards accelerated computing. Accelerator complement CPU-based architecture and deliver both performance and power efficiency. Moreover, modern data center, as we know, can be used by several different users to serve different workloads, and the idea of having an underlying architecture built on reconfigurable technologies seems to provide an ideal fit for these changing, demanding workloads. A final aspect that we do have always to keep in mind is also that FPGAs can deliver 10x and more acceleration across a broad set of applications, such as machine learning inference, data analytics, video processing, genomics, just to name a few. Within this context, we can easily understand why a company like Amazon, which built a unique position in infrastructure as a service with the Amazon Web Services Elastic Compute Cloud, is trying to extend its position to applications that benefit from an acceleration using FPGAs. Not only, as we all know, FPGAs are quite difficult to program, and Amazon is creating the foundation to simplify FPGAs adoption by creating a marketplace for accelerated applications built on Xilinx FPGAs. This is great, but we may still have some issues in understanding cloud computing and its rationale. The best definition we can find for cloud computing is the one given by the National Institute of Standards and Technology. The NIST is a technology agency that is part of the US Department of Commerce that works with the industry to develop and apply technology, measurements, and standards. Its definition of cloud computing is the following. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, such as networks, servers, storage, applications, and services, that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model promotes availability and it's composed of 5 essential characteristics, 3 service models and 4 deployment models. Okay, I can see your point. This definition can be improved, but I think it can be considered as one of the best definitions at the present days. After this brief introduction on why FPGAs can be an interesting platform to be used to extend the cloud computing architecture, let us now try to see why we may be interested in using such a solution. Let us consider our typical workday. No matter how hard we are working or how fast we are not capable of getting the full benefits out of the resources we have available in our computers. The best we can get is about 10% of the processor, 60% of memory, and 20% of network bandwidth. And this is the best. The normal levels are considerably less on average. Now, we are capable at best to get the usage, but we are still okay with paying for the entire 100% of the resources up front when we are buying our computers. There must be something wrong with us. Well, the scenario is even worse. The example we made is not only valid for the resource available on our computers, but this is also true for our networking costs. Most internet service providers have a lock-in period that commits you to their customer base for at least a year. Now, the case of a single computer may not be the best one. But what if, instead of a single computer, we will target hundreds or even thousands of computers that are used at a nominal rate? A scenario in which we may be working with hundreds of thousands of computers is the one where we are targeting a data center, which implies that we may have also different kinds of servers, such as web servers, application servers, and database servers. Now, these servers are different in terms of resources, but they are all experiencing the same issues we were previously describing. They are all underutilized in terms of resource usage. Wouldn't it be good to pool and share the unused resources of all these servers and put them to good use? Otherwise, we need to invest upfront for computing resources that may only be used occasionally. which does not seem to be a good idea at all. Why pooling and sharing resources can be a solution to this inefficiency? Quite easy. By sharing resources, we can make them available to others in the same organization. Now, this seems a viable solution, but let us try to see if we can come up with something different. As an example, what if we can pay only for the resources that we are going to use? This is a scenario in which we do not need to pay upfront in purchasing all the resources, but it consists in simply signing up with a service provider on a pay-as-you-use billing model for meeting our computing needs. Now, this is exactly where cloud computing comes into play. Within this context, what is the reason why FPGAs can be an interesting solution for cloud infrastructure? What is going to be the benefit from a cloud provider or from a user perspective? Is there any cloud provider already using FPGAs in their system? Those are the questions we are going to find an answer to in the following classes. Therefore, if interested, continue to follow us in this incredible journey.